types of units. You guys have already identified vector versus scalar units. Simple definition, what are vector units? They have magnitude and direction. Units with magnitude and direction. Whereas scalar units are ones with what? Magnitude only. All right. Now, hopefully that's something that you guys already knew, but if it's not, let me see if I've got something real quick here. Oh, we are totally going to. Yep, you got it. It's probably like every science teacher's favorite clip of a cartoon.
Yes. I mean, it doesn't get much better. This is the most. Look how cool that is. Oh, look at that color. By the name of that's a mathematical term.
Science teachers.
With both direction and magnitude.
Everyone else in the building.
Both direction and magnitude. Oh yes, science life for us. Every single corner you have like that. Give it a demonstration.
No. So, again, vectors are units with both direction and magnitude. So let's go ahead and list a handful of units and see where they belong. What unit goes where? Someone give me a unit of measurement. Okay, what are you measuring with centimeters squared? Area. So where should area go? Vector or scalar? Scalar. Last I checked, we don't measure miles, square miles north. That doesn't quite make sense. Area. I mean, I suppose. But typically you'd measure that linear distance still. All right, other units, where would they go? Other things are units of measurement. Volume, scalar. Did you just say pi? Pi is not a unit of measurement. It's a radians, there we go. Radians, what do you think, scalar or vector? So radians and degrees are kind of tricky in here because typically that's what we use to give direction. And we can still talk about them from the x-axis, from the y-axis, or if we're talking just absolute radians, so 2 pi radians is always going to be along the negative x-axis. Given that they're really more so the direction, I'm going to go ahead and put angle over here. What else? What other units? Velocity, all right? And its counterpart? Speed. What other things can we put in here? Time. Okay, I'm putting time into a scalar category because I don't want to deal with the idea that it can have direction. Yeah, we don't want to talk about that. So we're going to put it in scalar. All right, what else? Length. Distance. And what would be the vector version? What would be the vector version of distance? You're not wrong. How about displacement? What else? What else can we put on our list? Density's fine. Yeah, it's a scalar. Absolutely. I heard mass. Ooh, weight. Where does weight go? Why vector? X down. Absolutely. So weight. Say again. Force. Buoyancy. I'm going to put that as a vector, and really that's just a specific kind of force. Also a specific kind of force. I heard acceleration. What else do we have? I can think of at least one that should be pretty obvious that most people measure daily. Temperature.
How would you measure it with like
Measuring energy is typically can be temperature, but I will definitely put amounts of energy here. On this side, I'm going to put momentum. On this side, I'm going to put charge.
and then charge? Is that like
Like electric charge.
like everything is related to
No, there's a lot more options there. Current. Current's typically a vector. Voltage would be over here. Resistance would also be over here.
capacitance?
Now you're getting into awfully things. All right. So the similarities between these ones are that they all have a direction. Over here, a direction doesn't necessarily make sense or really doesn't make sense at all. Okay? So the ones we are going to be focusing on for the first chapter are acceleration, velocity, displacement, and time. Yeah, we're going to also talk speed and distance, but we're not going to focus quite as much on those. Yeah, Habiba. Resistance doesn't have a direction because it simply acts in opposition. Typically, it's a, think about this one a little more. It has to do with how the material is made, and it doesn't necessarily act in a direction. It's simply a way of using energy. So it's more closely related to energy and the rate it's used at than it is to anything working left or right. If I said 6 ohms right, what? And when we get to electrical currents, that'll make a little bit more sense. Current we can have a direction on because 6 amps to the right, okay, the current is going this way in the wire. That makes sense. We're not talking what ifs. All right. So this brings us to one-dimensional motion. Okay. Talking one-dimensional motion, we're just going to give a quick definition for the variables we just highlighted. So displacement is simply the straight line distance between 2 points, or the measured change in position between 2 points. The straight line distance between 2 points. All right, so displacement, straight line distance between 2 points. Distance is the length of the path traveled. Is length of path traveled. All right. Following that, we've got speed and velocity. Speed is an average rate of motion over time, whereas velocity is typically considered instantaneous and is always the rate of motion or rate of change in position over time in a specific direction. Speed, average rate of motion, whereas velocity is typically an instantaneous change in position over time. Change in position over time with a direction. And lastly, acceleration. And acceleration is a rate of change in velocity over time in a specific direction. Of change in velocity over time in a direction. I'm thinking on that. You still would. Yep, you still would. Because we could be taking an absolute value here, in which case the direction would no longer matter. We do want to maintain that it is clear. We do want that direction to still exist. Okay? Right? You're going to ask that question about 3 more times before the week's over. All right. So, first thing I want us to do is we're going to plot a distance versus time graph and a displacement versus time graph. Distance versus time and a displacement versus time. No. Okay, and actually, I should draw this a little better. I should have negative axes as well here. So what we're going to do for this one is I'm going to stand in the middle of the room and I'm going to walk back and forth in certain directions, counting different amounts of time, and we're going to plot that to start on the distance versus